Does anybody have any questions or comments before we get started? Any problems you want to bring up, or nobody has anything to offer today?
Both classes are just 0314.
What do you mean? Record? Yes.
From the 13th.
Oh, you can ask a question from any class. Well, let me specify. It needs to be math.
Oh, it's math.
Okay.
I actually.
Okay. Angel. Okay. So 7.4. Actually, I looked at the schedule, and it looks like 7.4 is to be covered in both classes today. It's actually on the agenda for both classes, and so I'm not sure that I can make it last 2 full hours, but I'll teach up to 7.4, and then as soon as I've covered it completely, we may just call it a day today, okay? All right, so here we go, 7.4. If you want to follow along, that's page 477. And this section is on quadratic equations and functions. So it's all about the quadratics today. And the first thing we need to do before we jump into any examples is I need to give some introductory formulas to set you up so that we can, go through the problem. So the first formula anybody seen that before? Maybe in some other math class, maybe in public school. Anybody seen that before? That is your standard form of a quadratic equation. And you probably remember this because you needed to find A, B, and C to plug into the quadratic formula. So again, this is called standard form. Of a quadratic. Notice that it does have to be equal to 0. And the exponents need to be in descending order. So if the exponents start at 2 and then 1 and then none, if they go down in order, did you notice that the coefficients are in alphabetical order? A, B, C. Next, we got another form. And I'm not sure, you may or may not have seen that before. Anybody recognize that form? Yeah, okay, so that one is called vertex form. That is the vertex form of a quadratic. And the reason it is called vertex form is because the ordered pair h comma k is the vertex of the parabola. So if you have an equation written in this format and you see a number where h and k are, you can take those values and it gives you the vertex of the parabola. And does everybody know what the vertex of the parabola is? Y'all know where the vertex is located on a parabola? Yeah, it's at the bottom of the U, or if it's upside down, it's at the top of the U, right? So the vertex is either the lowest point or it's the highest point, depending on the orientation. Okay, so there's the two forms we're looking at. Next, we're going to look at techniques for how to solve a quadratic. Talking about how to solve a quadratic, and there are 3 techniques we're going to look at. And the first and probably the easiest is factoring. And we may have already solved some quadratics in here by factoring. And y'all know what I mean when I say factoring, right? Like factoring the difference of squares or factoring a standard trinomial, stuff like that. So that's a technique. But does every polynomial factor? No, they don't all factor. And so we need a backup plan, and that's the quadratic formula. And I'm sure that most of you were required to memorize that in public school. And so y'all already know what that is, right? You have it memorized? Maybe not? Okay, so yeah, we'll go through that in a minute. The third technique we're going to look at is called completing the square. And we're probably not going to do that very much. I mean, it turns out that it's useful in a few things later in math, but if you have factoring, which is fast, and the quadratic formula that works every time, the completing the square is just like another option. And I have to teach you, it's in the curriculum. Got it? Now, let's talk about the quadratic formula before we go on. And if anybody has that memorized, I'd like you to go ahead and give it to me. Anybody know the quadratic formula by heart? What is the part you know? Okay, something with C. Okay, and then you know it's all over 2A. Okay, so you got most of it, okay? So what I'd like to do to get the rest of it is I'd like to teach you the quadratic formula song, and that way you can learn it and it'll stick with you if you learn the song, okay? So are y'all ready for the quadratic formula song? All right, here we go. It goes, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Yeah. And if I didn't already mention it, I did record myself doing that and put it on YouTube, so you can watch it over and over and over again. And it's important, okay? I've got 4 kids myself, and I teach them all the song at age 5. At age 5, I was teaching them that song, okay? Yeah, we didn't do nursery rhymes. We did the quadratic formula song.
They have no idea what it is because they go to school.
Yeah, later they'll have it, though. They couldn't do the math, but later they'll know it. All right, so I think we should do that one more time. Now that you have it written down, y'all watch and maybe try to pick up on how the song. And did anybody recognize the tune? Pop Goes the Weasel. Yeah, it's my favorite. All right, here we go. One more time. Ready? X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Got it? Super easy. You need to learn that so you can pass it on to your kids. And at this point, we've got everything we need now to work problems. So now we're going to start with our first example, number 1 in the text. Problem number 1, page 477, and the instructions say solve. They want me to solve for x. So the first thing that we want to notice is that the equation is equal to 0. Did you notice that? And also notice that it's not in standard form because I don't see the individual terms. What I see is factors. So I don't know if you noticed this or not, but what they've actually done is they've done the factoring for me. And so all I need to do is set each factor equal to 0. Yeah, this basically has no work to do. It's already been set up for me. We're just going to set the factors equal to 0 and solve. And so we're going to move the minus 3 over. And remember, that makes it become a plus. And then divide by 2. X equals 3 halves. So far, so good? Next, we're going to move the minus 2 over. That makes it a plus 2. And divide both sides by 3. X equals 2/3. And we're done. Anybody have any questions about that? Anybody? Are y'all ready for another one? All right, here we go. Let's do another one. Next problem, number 3. And for number 3, we have x squared minus 8x minus 20 equals 0. So is it pretty obvious to everybody that this is a quadratic? Right? It's got an x squared and no bigger power. Is it in standard form? Yes, it is. I can see that a is 1, b is -8, and c is -20. I can see the a, b, and c. But since it's in standard form, and since factoring is fastest, we're going to try to solve this by factoring. If it doesn't factor, we can always sing the song. But if it'll factor, that's the fastest way to get the answers. So can you read the signs? Minus at the back makes them opposite. X and x to make x squared. And the numbers that multiply to make 20 and subtract to make 8. 10 and 2. And does everybody understand the 10 has to go with the minus? Because 2 minus 10 is -8. Isn't that great? And so now that it's factored, I can set each factor equal to 0. And moving the 2 over gives me -2. -10 comes over, makes +10. Anybody have any questions about that? How many answers did we get? What about on number 1? Does every quadratic have 2 solutions? Yes, it does. Every quadratic has 2 solutions. And just to demonstrate that, we're going to do a special one. This is my problem. I'm going to make it up. All right, so again, here we have a trinomial, right? It's got 3 terms, definitely quadratic. It is equal to 0, right, in standard form. And again, we're going to make an attempt to factor this. So can you read the signs? Yeah, they're both going to be minus. X and x, and the numbers. 9 and 9. Everybody see that? So now this is factored completely. And now do I need to set each factor equal to 0? Did you notice those factors are identical? So if I set them both equal to 0, am I going to get the same answer? Yeah, so in this case, I really only need to set one of them equal to 0 because the other one will produce the same answer. So we're going to get x equals 9. And it appears that there's only one answer, right? But there's actually two, okay? It just happens that the two answers are identical. So we'll get x equal 9 and x equal 9. Y'all understand? There's still two solutions, even though we can write it as one answer. And later you're going to find out the fact that if you have a repeated solution, it means something about the graph. Any questions so far? Okay, next problem, number 15. And now we're going to crank it up a notch. So is this equation quadratic? In other words, does it have an x squared? Yeah, it's got an x squared and no x to the third, fourth, fifth, no bigger power. So it is quadratic. Is it equal to 0? Well, guess what it needs to be? Equal to 0. Yeah, so in this problem, we're going to have to make it equal to 0 by bringing the 6x over. And then instead of a trinomial, we have a binomial. And so in our mind, we're thinking, okay, I'd like to try to factor, but there's only two terms. So my option is maybe there's something that I can factor out. Do these two terms have something in common? What? A 2 and an x, right? And so I'm going to be able to factor out a 2 and an x. What will that leave me with? Does everybody agree with x minus 3? Everybody see why it's x minus 3. And now that it's factored, I can set each factor equal to 0. And for the first factor, we're going to have to divide by 2. And what is 0 divided by anything? 0. And y'all know that's not really true. There is one number you cannot divide 0 by. Anybody want to guess what number that is? 0. You can't divide by 0. But 0 divided by anything else is 0. And for the other factor, we're going to move minus 3 over. And guess what? We get two answers again. Yay. Anybody have any questions about that? Do we need to do any more examples that involve factoring? Are you ready to move on and try a different technique? All right, okay, good. So we'll move on then to number 29. And we've got x squared plus 6x equal to 7. That's the way this equation starts out. And for number 29, the instructions say solve by completing the square. And so this is where I get to show you how completing the square works. So are y'all ready to receive my instruction? Okay, here, what I'm about to say is important. When you're completing the square, you don't want it equal to 0. When you're completing the square, you want the constant to be on the other side of the equal sign. So do you see that this problem is already kind of set up how I need it to be? I've got the x's on one side, I've got the constant on the other, this is the way you want it to be in order to complete the square. So the next step is going to say this. We're going to make a place for us to put a special number that we're going to come up with. And whatever I do to one side, I have to do to the other. So we're also going to put a special number on the other side. The box is a placeholder for the number we're going to come up with using the completing the square process. So are y'all ready to see how we generate that special number? Yeah, okay, it's a two-step process. We're going to take the coefficient of x, which is 6 in this case, and we're going to take half of it. And then whatever that works out to be, we're going to square it. And then whatever that is, that's my new number. So the process of completing the square says you take half of the coefficient of x and then square it. So half of 6, 3 squared, bam, and there's the special number. And whatever I do to one side, I have to do to the other. So we're going to put a +9 on both sides. Have I lost anybody yet? No? Okay, I'll keep trying. Now, if you look at what I've created, I now have created a trinomial that's going to factor nicely. So let's see if we can factor this trinomial we just created. Can you read the signs? They're both going to be positive. X and X. And the numbers. What was that? 3 and 3? 3 times 3 is 9. 3 plus 3 is 6. Oh, and did you notice those factors are identical? And so that means I can take one more step of simplification. Anything times itself is that thing squared. And that's what I meant when I said it factors nicely. It factors as a perfect square trinomial. It's always going to factor down to where those factors are the same, okay? That's what's special about completing the square. And then we need to do the math on the other side. 7 plus 9? 16. And if you've been able to keep up to this point, from here on out, it's downhill. We're basically coasting from here, okay? So what do I do to get rid of a square? What gets rid of a square? Square root. So we're going to square root one side to get rid of the square, but whatever I do to one side, I have to do the other. And the 16 square root. Four. And one more thing you need to remember, whenever you take the square root of both sides, you do get a plus and a minus answer. So that is going to be plus and minus 4. And then I can bring the 3 over, and that's going to get x by itself. Yeah, so that's going to give me -3 plus or minus 4. And then at this point, we can do the plus and the minus to get our two answers. So what is -3 minus 4? -3 minus 4. That's -7. -3 minus 4 is -7. Now, what about -3 plus 4? That's the 1. And now I'm done. Got my two answers. And that is the method of completing the square. And now if y'all want to see that again, y'all can go back and watch the video, okay? I don't really intend to do more examples of that. All right, so who's ready for another problem? Anybody else ready? Okay, so the next problem we want to do is number 29. Yeah, we're going to do a Britney Spears. You know what that means, Britney Spears? Oops, I did it again. We're going to do it again. I worked the same problem and got the same answer. Oh, baby, yeah. All right, so let's assume that we have this same problem and we don't want to complete the square. Let's say we don't want to do that. What would be the first step I need to do? Yeah, set it to 0. So if I don't want to complete the square, I need to put it in standard form. Make it equal to 0. And then if you want, you can try to make it factor. So are there numbers that multiply to make 7 that subtract and make 6? Yeah, 7 and 1, right? And then we can factor that. We can set each factor equal to 0 and solve. Guess what the answers are going to be? Do I need to show that? Okay, you know what? I think I will. Bam, bam, bam. All right, can you read the signs? Different. Good. X and X. And does the 7 go with the plus or the minus? And has everybody figured that out now, how to tell where they go?
I get mixed up on.
Yeah, let me tell you how to tell every time, okay? Because I have a nice little,
Oh, you said the other day,
yeah, I have a nice little thing. I'm going to re-emphasize though, okay? Even if I said it the other day. The way you tell which one goes with the plus or the minus is you ask yourself, which is bigger, 7 or 1? And the big number always goes with the first sign in the problem. So whichever number is bigger, that's going to go with the first sign. I didn't say it down here, did I? I said the first sign in the problem. And so the 7 has to go with the plus. And then some of you are thinking, well, wait a second. The way I tell is 7 minus 1 is 6. It makes that. Yeah, that works too. And then I'm going to set each factor equal to 0. And I'm going to move the 7 over and the minus 1 over. And guess what? Same answers. Different technique. Any questions? Anybody? Go ahead, Aaron.
Is there a time you're gonna, do we always have the option of either one, or is there a point where you want us to do one or the other?
Unless the instructions specify which way they want it done, you can choose. Okay? And so on the next test, I may specify solve the quadratic equation using completing the square, must show work to get credit, something like that. Yeah. That's pretty hardcore though. All right, y'all ready for another one? Okay, let's do number 29. Oh, I love that look, Noelia. That was great. You're looking at me like he's lost his mind. Why, right? I'm going to do it a third way. We're going to do the same problem again. So let's bring the 7 over. And can you guess the technique I'm going to use this time? The one we haven't done yet. Quadratic formula. We're going to sing the song. So what is the value for A? Remember, A is the coefficient of x squared. So here A is 1, B, and C. And please make sure that you include the sign with the number. You got to take the negative with the 7 for C. Everybody see what I did there? Did you know that it has to be equal to 0 to pick A, B, and C correctly? Yeah, okay. And now that we know those values, we're going to sing the song. Ready? All together now. X is equal to negative B plus or minus the square root. I can't hear you. B squared minus 4AC. Come on. All over 2A. That was terrible. I didn't hear y'all at all. I'm going to make y'all learn that. It's going to be part of the next test.
What's the last part? It says 36 minus 4 times 1.
Yeah, it says 36 minus 4 times 1 times negative 7.
Is there an easier way to put that?
What?
Isn't there an easier way to put that?
No, because that's the formula.
Okay.
Yeah, so it's,
Oh, okay, I know what you're saying now.
so here's B, so negative B plus or minus square root of, everybody see where I got the 36 from? B squared, 6 squared, minus 4AC all over 2A.
Have to know the formula to know what it is.
Yes, that is correct. And now I'm going to need some calculator assistance. Can somebody calculate the number under the square root for me? I want to know what is 36 minus 4 times 1 times negative 7. Is it 64? Okay, Isabel verified it is 64. And the 64 square root. Square root of 64? 8. And then at this point, we want to do the plus and the minus separately. So what is negative 6 minus 8? Negative 6 minus 8. But then that number has to be divided by 2. And there's one of my answers. And then we're going to go back and we're going to say negative 6 plus 8. Negative 6 plus 8. But that's going to be 2 over 2, which is, wow, and look at that. Get the same answer. Is that not cool? I did the same problem 3 different ways and got the same answer every time. Math is awesome.
The last one was the quadratic formula.
It is. The last technique was the quadratic formula.
And the one before that one was
Factoring.
what was that?
And the one before that was completing the square. So there's the, I don't know about y'all, but that's nice notes to have the same problem. It's kind of organized in your notes. Bam, bam, bam. All 3 techniques with the same problem. Math is so fun. All right, so let's add a page, and if y'all are ready, I got another one for you, okay? Number 55. And the instructions say solve. And it doesn't specify, I'm sorry, it does specify. It says use the quadratic formula. It does specify. Yeah, so if I'm going to use the quadratic formula, what is the first thing I have to accomplish? Yeah, I have to set everything to 0. So we're going to bring the minus 2 over. And did y'all notice that this quadratic does have a lead coefficient? Y'all see the 5 in front of the x squared? And so even if I wanted to factor it, that's going to require the 3R method, which you may not enjoy that. So you might want to, embrace the quadratic formula because it does work every time. And if you're good at it, it doesn't really take that long. Oh, and it gives you an opportunity to sing. So what's the value for A? B? C? And now that I know all 3 of those values, we can plug into the quadratic formula. Are y'all ready to sing? Yes. Okay, so here we go. X is equal to negative B plus or minus the square root of B squared minus 4AC all over 2A. Y'all are not into this singing stuff at all, are you? Is it you don't like the tune? Would you rather switch it to Smells Like Teen Spirit or something? How about this? Does anybody have any questions about any piece of that? Or do y'all understand why all the numbers are what they are? And now I need some calculator assistance. I need you to calculate the radicand. Matthew, can you give me just the number under the radical? Without the square root, just the number under the square root. Ah, that's what I want. And you're demonstrating that the calculator I recommended actually does more work for you, yeah. Y'all see that? That I actually get a negative? And does everybody understand what happens when we get a negative under a square root? The negative comes out and turns into what? I agree. So that's going to give me negative 2 plus or minus, what is the square root of 36? 6. And the fact that it's negative makes it complex. Gives me an I. All over 10. And now, does 2, 6, and 10 reduce? What goes into all 3 of those? 2 does. So the final answer is going to be negative 1 plus or minus 3I over 5. And if you write it the way that my math lab is going to want it, it's going to be negative 1/5 plus 3/5 I and negative 1/5 minus 3/5 I.
Both of them are negative 1/5 though.
I'm sorry? What?
I'm trying to follow where the negatives are, so still stays at negative 1/5 in the answer. Then one is plus and one is minus, okay.
Right, because the 3I gets to be plus and minus. But the 1/5 is negative 1/5 both times. Anybody have any questions about that? Okay. I think I'm going to share bonus material with you. Is that okay if I give bonus stuff? It turns out that those of you that have my calculator, I've got some good news for you. If you have the Casio, I'm going to show you how the Casio can produce these answers for you. Are you ready? So please, would you push mode 2? And what mode 2 does is it puts the calculator in complex mode so that it can display complex answers. And then push mode 5.3. Mode 5.3. And then it's going to ask you for A, B, and C. And if you just enter 5 equals 2 equals 2 equals, and then push equals one more time, it's going to give you the first answer here.
You press what? 5?
Let's start over again, okay? Mode 2 to make sure you're in complex mode. And then mode 5.3. Mode 5.3 is the quadratic solver. And all you have to do is input A, B, and C. And then if you hit equals, does it give the negative 1/5 plus 3/5 I? Does it give it like this? How freaking cool is that? What if you hit equals again? Does it say x2 and give the other one? Holy crap. So it gives them both? Hey, what if you hit equals again? Does it say x minimum? What is that number? I'm sorry? Negative 1/5. And if you hit equals again, and what is that? Yeah, so let's talk about all the stuff the calculators give. The calculator just vomited math all over you, okay? Let's talk about what it's giving you. First of all, when it says x1 equals and x2 equals, it's giving you the solutions. Those are the answers. Hey, I'm not done. Those values for x1 and x2, if you think about the graph, is a parabola, right? Those solutions are the x-intercepts. So not only does it give the solutions to the equation, but it gives you the x-intercepts of the graph. And now let's talk about what this other stuff is here. X minimum and Y minimum, if you put those together as an ordered pair, what the calculator has actually given you here is the vertex of the parabola, which is really nice, because later we're going to ask you to find that. We're going to say, what's the vertex? And notice the calculator gives it to you. Are y'all getting all this down? If not, it's being recorded. Y'all go back and watch it again, okay? Man, and all of this stuff down here, that's not even stuff we need right now. That comes later. But now you know how to get it. I'm sorry, what is that again? The vertex. It's the vertex. Questions? I'm sorry, anybody have questions? I got a question for you then. Did y'all hear me say that the solutions are the x-intercepts of the graph? What does it mean if the solutions are complex? What does that tell me about the x-intercepts of the graph? No? What? Liz, you want to throw something out? No. Okay. If the solutions are complex, what does that tell me about the x-intercepts of the graph? Well, and what does that mean? If the x-intercepts are complex, what does that mean? Come on, people, somebody. I'll say it again, okay? Yeah, here's the vertex, right? And the solutions of the equation, which are the x-intercepts of the graph, they're complex. So what does that indicate about the x-intercepts of the graph? If the solutions are imaginary. No, they're definitely not the same. They're kind of opposite. Okay, I'm getting frustrated.
I missed where you got that 9/5.
You missed where I got the 9/5? That's from the calculator.
Well, that's why it's not gonna calculate.
Yeah, so the negative 1/5 and the 9/5, they come from the third and the fourth output from the calculator. Yeah, so I'm about to show you then. So we have y equals 5x squared plus 2x plus 2. There you go. There's the parabola. There's the vertex. Is that actually right? Negative 0.2. What is negative 1/5 as a decimal?
0.20.
Yeah, negative 0.20, which is right. And what is 9/5 as a decimal? And that's also verified here. Do y'all see that? That the vertex is verified with the desmos. And now I'm going to get my question answered that y'all wouldn't answer a while ago. If the solutions of the equation are complex, what does it indicate about the x-intercepts of the graph? Say it again? They're definitely not whole numbers. In fact, they're definitely not what? Does that parabola cross the x-axis? So that if the solutions are complex, it tells me the x-intercepts don't exist. There are none. So not only are they not whole numbers, they're not even real numbers. They're imaginary. Man, are y'all going to write that down? If the solutions are complex, then the x-intercepts don't exist. There are none. I'm so glad y'all came today just to get that. Okay, and in the last couple of seconds before I take a break, I'm going to give you just the slightest bit more bonus stuff, and then we'll take a break, okay? So, if at the very beginning, if this would have been a function, f of x equals this function, and they said graph, with the calculator, with the Casio, it will generate the vertex, right? And I know that a negative x and a positive y is going to be in the second quadrant. Negative x, positive y, that says I'm going to go back and up, right? And if the a is positive, that means the parabola opens up. If a is negative, it opens down. So just with these two pieces of information, the vertex and the fact that a is positive, look, I got the parabola. Y'all see how freaking easy that was? The calculator gives me the vertex, the a tells me it opens up, bam, I got the graph right there. And from that little bit, you can verify, hey, no x-intercepts, which verifies this is complex. Yeah, okay, let's take a break.